Greetings, period 2 and period 4. Hope you're all doing well. Having a great day. I'm right now at this moment probably packing up all my stuff at home and moving it all to my new home. I'm sure I'm having an absolute blast. But I promise I would rather be there in class with you right now. I promise I'm thinking about you as I'm packing up all my stuff. All right. So I decided to try to make this short video here as part of your class today because I want to finish up this section in chapter 15 that we were working on last time, which is section 3. We had gotten to the point where we had solved some of these equations but hadn't solved some of the other ones. So if you go ahead and open up to where we left off in section 3, and that's what we're going to do. Sorry, my video quality is not very good here. I'm using my backup webcam. My good one's at home, so I'm having to use the other one here. But let's get right into this. Now, I will say period 4, you got a little bit further than period 2 did, just because period 4 is a lunch period, and we just, had some extra time. So no offense, period 2. Okay, you didn't do anything wrong. Just period 4 has longer periods. So period 4, you might kind of see a couple of repeats here of what we did in class. That's okay. If you want to fast forward through it, fine, but it probably doesn't hurt to see things more than once. You know what I mean? Okay, so let's see if I can share my screen here. Hopefully it focuses, and it did. All right, okay. So period 2, we did all of these problems here. I'm on the third page. I'm on the third page of section 3, and we did all these, but we kind of skipped this one right here. So I want to point out that this problem is very similar to another one that we know how to solve. And I'm just going to use this space up here. And that would be x squared minus 4x minus 5 equals 0. And I want you to kind of notice the similarities between these two equations. For this x squared term, it just means something's being squared. Well, look at e to the 2x. Is something being squared there with e to the 2x? It is. There is something being squared there. The thing being squared there is e to the x, right? E to the x squared is e to the 2x. So just like in this equation where x is squared, we have something being squared in this term as well. Notice in the next term then, whatever was squared in the first term is just kind of all by itself now. Just like here, e to the x is being squared, and now e to the x is all by itself. And then we have our constant term. Now we know that to solve this quadratic equation, we just write it in factor form, x minus 5 times x plus 1, and then we find the value of x that makes each of those factors equal 0, which would be negative 5 and negative 1. Well, we're going to do something similar here to solve this exponential equation. We're still going to factor it. And I know that seems weird to factor, but it's not that bad, because notice that the first term in each factor is just going to be e to the x, because when I FOIL this, e to the x times e to the x gives me that e to the 2x. And my last times last is going to be the same as it was up here, which is negative 5 and positive 1. And so there's our factored form. Let me go ahead and make myself a little bit bigger here. Hello. All right. Now we just set each of these factors equal to 0 and solve them. So if e to the x minus 5 equals 0, that means e to the x equals 5. And if I change this equation into logarithmic form, I get that x is the natural log of 5, just changing this exponential form into logarithmic form. E to the x equals 5 means x equals natural log of 5. Remember, the log will equal the exponent, and the exponent was x. Now with this other one, e to the x plus 1 equals 0. That means e to the x equals negative 1. And here's the thing, e is a positive number. There's no way you can raise a positive number to any exponent and get a negative answer. So e to the x can't equal negative 1. We're just not going to get any solutions there. And natural log of 5 is our only solution. So a logarithm is the solution to this exponential equation. All right, moving down here to this problem, again, period 4, I know we did this one already. Period 2, this is a problem that we really have learned to solve already because we can add these two logs together by multiplying their arguments. So x plus 2 times x is x squared plus 2x. And now I have two logs that are equal to each other. And if the logs are equal, then the arguments are equal. And so I can just state that x squared plus 2x has to equal 8. And now we just solve that equation. Well, that's a quadratic equation. We're kind of in quadratic mode today. So I'll subtract the 8 and then I'll factor x plus 4 times x minus 2. Find the value of x that makes each of these factors equal 0. And that would be -4 and +2. I want you to notice, though, that if x is -4, if I put -4 in for x in this argument, that's going to make this the natural log of -2, right? It's going to make this argument negative. It also makes this argument negative. That means -4 is an extraneous solution. 2 would make both of the arguments positive, so 2 is a legit solution. This equation has one solution, and it's 2. All right, on the back page here, we've got a few other equations to solve. And some different stuff's going to happen here. Now, on a problem like B, this is so easy, right? We've already got the two logs equal to each other, and we just state x plus 3 equals 2, right? If the logs are equal, then the two arguments are equal, and that means that x equals -1. I want to point out here that this -1 solution is okay, because if you put -1 in for x in this argument, -1 plus 3, that's still a positive number. And so it's totally fine to have a solution that is a negative number. We just have to make sure it doesn't make the argument negative, okay? Let's see. You know, there's another one like D down here that we already know how to do. So just for the purposes of today, I'm trying to keep this video shorter. That's one that maybe you can look on Schoology and see my completed work on Schoology there. E is another one that we already know how to do. That one's more complicated just because there's more properties to use. But again, we've already learned the principles for doing problem E. I'm gonna encourage you again to go on Schoology and look at my work for solving both of those, but there's no new math concepts involved there. I'm going to focus on these other three problems to try to keep this video as short as I can, okay? So for problem A, first of all, we can just use our property here. These two logs are being subtracted, so we can combine these two logs by dividing their arguments. So I'll have the log base 2 of, okay, I'm going to divide these two arguments. That'll be x plus 2 divided by x minus 1 equals 3. Now, what's unique about this problem is that there's no log on the other side, right? In problem B, I had the log of one thing equals the log of another thing. I had two logs that were equal. I don't have that here. So I can't, you know, I'm not in the situation where I can just set these two arguments equal. What I can do, though, is to just change this logarithmic equation into exponential form. And that's really all that I need to do. The base of this log is 2. So when I'm changing this into exponential form, the base of my power will be 2. The logarithm will equal the exponent. This log equals 3. So the exponent must be 3. This power will equal the quantity that was inside the log, right? That's the argument, but we also call it the power. The power will equal this quantity inside the log, which is x plus 2 over x minus 1. Now, at that point, the logarithm part of this problem is over, right? We did the log. All we have to do is just use our equation solving skills to solve this equation. And I'm going to walk through how to do that, but this, you know, this is an equation we should be able to solve. So first of all, 2 cubed is 8. And then I'm going to clear my denominator here. So I'll multiply both sides by x minus 1. So if I multiply 8 by x minus 1, that becomes 8x minus 8. I'll subtract the 8x, giving me negative 7x on the left. Subtract the 2, giving me negative 10 on the right. And then divide by negative 7, so x is 10 sevenths. Now, if I plug 10 sevenths in here for x, 10 sevenths plus 2 is positive. 10/7 is bigger than 1, so 10/7 minus 1 would be a positive number. That's a legit solution, and I'll keep it. So when you don't have a log on the other side, we're just going to change that into logarithmic form. That's the same thing that's going to happen in problem C here. But I need to isolate this logarithm. In other words, I need to add the 3 over to the other side. So this becomes log base 3 of 2x minus 1 equals 1 plus 3 is 4. Okay, so I only have a log on one side. That means I need to change this into exponential form. The base of the log is 3, so the base of my power will be 3. The log will equal the exponent. This log is equal to 4, so my exponent is 4. This power will equal the quantity that's inside the log, which is 2x minus 1. There's the log step. Now we just solve it. So 3 to the 4th, hopefully we know by now that 3 to the 4th is 81. I'll add 1 to both sides, 2x equals 82. Divide by 2, and x is 41. If I substitute that into this original argument here, 2 times 41 minus 1 is definitely a positive number. So no extraneous solutions, 41 is my answer. All right, we've got one more to go here, which is example F. This one has a natural log in it. And the first thing I'm going to do is, just like last time we had a -3 to deal with, I'm going to add this 3 to both sides. So I'll have the natural log of, this is like the same problem. Almost the same. This had a positive 1 here. This one has a -1 here. But other than that, they're very similar problems. -1 plus 3 is 2. Okay, so same thing as before. We only have one log here, so I'm going to have to change this into logarithmic form. The base of this log is e, so the base of my power will be e. The logarithm will equal the exponent, so the exponent is 2. This power will equal the quantity that's inside the log, which is 2x minus 1. All right. The only thing different about this one is I'm not going to be able to get a nice integer solution here, or even just like a rational solution. My solution's not even going to be rational because it's got this e in it. But guys, you're just going to leave the e squared in here. Pretend like e was a variable, and you're going to solve for x, but you're just going to leave your answer in terms of e. For instance, I'm just going to add 1 to both sides. So now I have e squared plus 1. And then I'm going to divide both sides by 2. So now I have e squared plus 1 divided by 2. And that's it. That's your solution. Now, if we want you to get a decimal solution, we can have you plug that in your calculator and use your calculator to do it. If you want to say this is like 1/2 e squared plus 1/2, fine. Or 1/2 times the quantity, e squared plus 1, fine, right? All equivalent expressions. Okay, so that brings us to the end of section 3. I wanted to do this because I want to make sure that you guys that have my class today stay as up to date as possible with the class that has me on black days. So I felt like this was the best thing to do. I've got a practice assignment for you today that's just focused on solving some logarithmic equations. And then you can, so that you need to finish today. I don't care if you work with a partner on that, but you need to solve those equations and turn those into the substitute teacher today before you leave. That's due before you leave as a homework assignment. Then you have your 3 regular homework assignments that you can work on. And if you're finished with some of those, or you get finished with them, you can put those answers into Schoology and use that to check your work, okay? So plenty to do for the rest of the period today. Hopefully I made this video an appropriate length, but good luck, and I will look forward to seeing you next week.